Hello friends, in today's question, in the shown arrangement, both pulleys and the string are massless and all the surfaces are frictionless. Find the acceleration of the wedge. So this is a wedge whose mass is m1 and we have two masses which are connected through pulley, and here the mass, this is connected, okay, this is joint, they are not isolated with each other. So let us draw first of all the free body diagram for the individual masses, and then we are going to find out the respective equations. Okay, so we draw the free body diagram for m1, so this is mass m1. So we are going to have a m1 JEE in the downward direction, okay, and we are going to have two tensions, one tension in this direction and another one in the downward direction. There will be normal which will be acting on m1 in this direction because of mass m2, okay, and we assume that it is moving with a1 acceleration in this direction. So these are some of the forces which will be acting on the mass m1, okay. So based on this we can write the equation as the movement is only in the horizontal direction, there is no movement in the vertical direction. So we can say that as mass m1 moves only in horizontal direction, with acceleration a1, with acceleration a1 we get t minus n is equal to m1 to a1. So let us call this as equation number 1. Okay. Now let's draw the FPD for m2. So in this case we have this is our m2. In the downward direction we are going to act m2g, and we assume that it moves with the acceleration a2 in the downward direction. There will be a force of tension in the upward direction, and a normal will be acting, or reaction will be because of m1. Okay, so we can write this as normal because of m1. Now as m2 and m1 are interconnected, so m2 is going to have two types of motion. One will be vertical, another one will be horizontal. Okay. Now a2 we assumed that a2 is the acceleration in the vertical direction. So the horizontal acceleration of m2 will be same as that of m1. So you can say that horizontal acceleration of m2 is equal to horizontal acceleration of m1. So based on this, thus we get that n is equal to m2a1. So this let be equation number 2. And if a2 is the vertical acceleration, we can say if a2 is the vertical acceleration, we get, okay, so in vertical direction we have T force, T tension in the upper direction, m2g in downward direction, and acceleration a2 also in the downward direction. So we can say that m2g minus t is equal to m2 into a2. This is equation number 3. Okay, and if we draw the free body diagram for mass m3, so in mass m3 there will be only two forces, tension and m3g, and we assume that it is moving in vertical direction with acceleration a3 in the downward direction. So we get, if a3 is the acceleration, then m3g minus t will be equal to m3 times a3, and this is equation number 4. Next we are going to find out the constraint relationship between all the acceleration. Okay, you can say constraint relation between a1, a2 and a3. Now all the m1 is connected to m2, okay, and m2 is connected with the help of the string with m3. It means all the acceleration will be related with each other, and we can say that, which can be represented as a1 is equal to a2 plus a3. So let this be equation number 5. Now we have 5 equations, and we are going to use these 5 equations to find out the acceleration of the wedge. Okay. So first of all, let me write all these 5 equations here. So first equation was given as t minus n is equal to m1 a1. Second equation is given as n is equal to m2 a1. Third equation is m2g minus t is equal to m2 a2. First equation, second, third. We have fourth equation, that is m3g minus t is equal to m3a3. This is fourth equation. And fifth one is a1 is equal to a2 plus a3. So these are the 5 equations. Okay. So first of all, we are going to use equation 1 and 2. Okay. Using equation 1 and 2, we take the value of n, okay, and substitute in one equation. We can write this as t minus m2 a1 is equal to m1 a1. From here we can write value of t. We take a1 as common. We get m1 plus m2. Okay, and now we substitute this value of t in equation 3. Okay, we write from equation 3 we get m3g minus t, that is a1 m1 plus m2 is equal to m3 a3. Okay, and from this we can further write it as that a3 is equal to m3g minus a1 m1 plus m2 divided by m3. Now we are going to use the equation, one second, m3g m3 oh sorry, this is equation 4, not 3. Okay, this is equation 4. Now we use equation 3. Okay, we get from equation 3 we get, similarly we put the value of t. We get as m2g minus t is a1 m1 plus m2 is equal to m2 a2. From here we find out a2. So a2 is equal to m2g minus a1 m1 plus m2 divided by m2. Now we have value of a2 as well as a3. Okay, and this was our equation number 5. So we are going to put this value in equation 5. Okay, so we can write from equation 5 we get a1 and a2 is m2g minus a1 m1 plus m2, okay, divided by m2 plus we have m3g minus a1 m1 plus m2 divided by m3. Now we solve this. This is quite easy now. We write this as m2g divided by m2 minus a1 m1 plus m2 divided by m2 plus m3g divided by m3 minus a1 m1 plus m2 divided by m3 a1. So our m2 cancels here and m3 also cancels. So we get this as 2g. Okay. Now we solve this one. A1 as common. We get this as m1 plus m2 divided by 2 plus m2 and m1 plus m2 divided by m3. Now this can be further written as here it is a1. Now we bring this entire term toward one side, so we get 2g is a1 as common from the entire thing. We get 1 plus. Now we take as m2 m3 as LCM, m2 m3, and this we get as m3 m1 plus m2 plus m2 m1 plus m2. Okay. So it means we get 2g is equal to a1 m2 m3. Okay, now taking m1 as m2 common, we get m1 plus m2 into m2 plus m3 whole divided by m2 m3. So the acceleration a1 will be coming as 2g m2 m3 divided by m2 m3 plus m1 plus m2 multiply by m2 plus m3. So this is the acceleration of mass m1, okay, which was required. That is acceleration of wedge, okay, which is the acceleration of the wedge having mass m1, having mass m1. Thank you.